Hi, I am going to be going through how I would model for students how to approach an application style problem um, in general. So here's the problem. There are 15 colored pencils for 5 students to share. So I would stop them right there and ask, okay, so what operation do you think this is? There are 15 colored pencils for students to share. So when you think of sharing, and you hear this problem as 15 colored pencils, is that number repeating over and over again, or is that our biggest number that we're working with? Is that number going to change? And hopefully students would recognize, nope, we only have 15. That number is not going to change, and we're sharing it with 5 students. So that sharing should signal the making of groups to students, and hopefully they understand that the operation is division and can talk you through that understanding. Maybe they need to draw a picture of it first. But if they understand that it's 15, that's the number we're starting with. The next number in our division problem is the number of groups we're breaking it into in this case. And then the final number we're looking for is our quotient, which is going to be how many are in each group. So 15 colored pencils for 5 students to share. They each get the same number of colored pencils. How many colored pencils will each student get? So in this case, there's many different ways you could do this. You could break it up into 5 groups. 1, 2, 3, 4, 5, and separate out that 15 into each group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alarms going off that I passed out all 15 of my colored pencils. These boxes represent students, and each student I see gets 3 pencils. So our quotient in this case is 3. A big misconception that many students get when they get to their quotient is they are so driven to add all of their life that when they get this, they sometimes forget that the quotient is just what is in each group for this specific case. And so you really have to make sure that you see them, they're not going 1, 2, 3, 4, 5, 6, and really remind them, well, we already know what number we're starting with. We just passed those all out. So if you add those back up, you're kind of taking them back from what you just passed out or shared with your students. Okay, let's do another one. Mr. Jacobs' class is going on a field trip. They need to split into groups of 4 students. If there are 24 students in Mr. Jacobs' class, how many groups will there be? Well, in this case, this is a little bit different. They're telling us how many students are going to be in each group instead of breaking it up into teams, sharing it among friends, things like that. So we have to think about this a little bit differently. Again, I would first ask the students, do they think it's multiplication? Do we hear a situation repeating over and over again that would allow us to do something like 24 times 4? In this case, we only have 24 students. 24 students isn't repeating 4 times. So it's not multiplication, it is division. These 24 students are getting broken up into groups. But in this case, now they're telling us that there's 4 students in each group, and now the quotient is telling us how many groups we will have. So in this case, if you're having the student model this out and thinking about it visually, you would want to count by 4s. Here's one group because they want to be in groups of 4. So here's one group that equals 4, but we have to get all the way up to 24 students. So we make another group. Throw 4 students into that group. Now I have my students just write, where are we at? How many students have we figured out with those 2 groups? Well, so far we have 2 groups which equal 8. Some students will see, well, I have enough room to do 2 more groups of 4, which is another 8, which then equals 8 plus 8 equals 16. And I have more room, so I'm going to make another group. 16 plus 4 more, I'm at 20. And now I know I only have one more group to make 24 students split into groups of 4 students in each group. So now I just have to count. Now my quotient is the number of groups. So I have 1 group, 2 groups, 3, 4, 5, 6. 6 groups. So again, my biggest advice is to really have your student visualize what's happening. Really be thinking about it. Don't worry about the procedural aspect. Can they do this? We need them to really be able to think about the process, think about the problem. All right, there's one more. 225. Jason has 225 rocks in his rock collection. He divides the rocks into 5 equal piles. So now we know we're dividing these rocks into 5 equal piles. How many rocks are in each pile? Well, I see I have 225 there. I am thinking that I don't want to count by one. That's way too much to pass out. But I would start off counting by 20. Or if you have some baseball glass, things like that, this is always a good thing. But I understand at home, you probably don't have all the manipulatives that we have at school. So in this case, I would encourage my student to pass out by 20s and count up. So 20, 40, 60, 80, 100, and write down 100 below. Well, I know 100 plus 100 will equal 200, so I'm going to just pass out another 20 to each group. So now I'm at 200. Now I only have to pass out 25 more. Well, I'm going to test counting by fives. 5, 10, 15, 20, 25. That's going to get me to my 25, the last 25 I had. And now I did 225 divided by 5, looking for how many rocks are going to be in each pile. Now my quotient, I have to just add what's in one group. So 20, 45. So there's 45 rocks in each rock pile. So hopefully that helps for anyone looking to help their student at home. Thanks.